Hi everyone, in today's lesson we're going to learn about how to sum finite series. We could, just by the first example, it says determine the sum of the first 100 terms of this sequence, -1 to 1 to 3 to 5 to 7. Now technically I could just count out the first 100 terms and then add them, and that would be the sum. But that's a little bit drawn out. I mean, I don't want to go through all that effort when I can use a formula that'll give us the answer instead. So first you need to determine whether it's an arithmetic series or a finite geometric series. So let's look at the pattern. How do I go from -1 to +1? It looks like I'll have to add 2. Same thing when I go from 1 to 3 and then from 5 to 7. So that means my common difference, D, is 2. So this means we're going to use this formula here for an arithmetic series. So the formula is as follows. S of n equals n a sub 1 plus a sub n all over 2. And if we want to write the sum of the first 100 terms, the n is going to be 100. So this would be s sub 100, and that notation represents the sum of the first 100 terms equals n, which we made 100, a sub 1 is the first term, which is -1, plus a sub n, which is a sub 100, all over 2. Now, if I want to find the sum of the first 100 terms, I would need to find a sub 100, and then all I need to do is divide that number by 2, or after I use the formula, of course. So a sub 100 is the only thing missing for me to finish this formula. So a sub 100 is just the value of the 100th term. So we need to recall that formula for the explicit definition. So if I want to find a sub 100, I'm going to plug in 100 for n. And D is 2. And I actually can plug in a sub 1, which I know is -1. So if we throw this whole thing into the calculator just the way we see it, we will get the value of the 100th term. So take a minute, pause the video, and then do so, and hit resume when finished. Okay, I got 197 is the value of the 100th term. So that 197 I'm going to put right into here, and if you type this whole thing into the calculator, you will get the sum of the first 100 terms. So S sub 100 is equal to, now type all this into the calculator and hit resume when you're finished. Okay, I got the sum should be 9,800. Okay, let's try the next example. So the next example says, find the sum of the first 8 terms of this series. Now the difference between a sequence and a series is that a series involves you to just add them together, add the terms. So these terms pretty much came from -2, 4, and -8. So those were the terms, and if you add them together, you form a series. So that's really the only difference. So how am I going from -2 to 4? It looks like I'm multiplying by 2, or excuse me, -2, and then 4 times -2 is -8. So this means I have a geometric sequence where my common ratio is -2. And I want to find the sum of the first 8 terms. Now, since 8 terms is rather small, we technically could just count up to the 8 terms and then add them, but I want to practice with the formula. So here's the formula that I'm going to pull from here. This is the formula for the sum of a finite geometric series. So S sub n is equal to a1 minus a1 times r to the n all over 1 minus r. Okay, so I want to find the sum. So S sub 8, sum of the first 8 terms. My first term is -2 minus -2 times r, which is negative 2, to the n power, which is 8, all over 1 minus r, which is negative 2. So, which is nice, we all have those new calculators. If you type this into alpha y equals just the way you see it, you should get the right answer. So take a minute, type what you have there, and then hit resume when you're ready to see the answer. Okay, I got 170. Okay, that's it. That's the sum of the first 8 terms. All right, let's look at example 3. It's on the next page. Okay, so these are different variations. This one says, how many terms are there in a geometric series if the first term is 4, the common ratio is 3, and the sum of the series is 160? How many terms, that variable, how many terms, is n. So if we start with the formula, we have S sub n equals a sub 1, minus a sub 1 times r to the n, over 1 minus r. So let's plug in what we have. We have the sum of the series of n terms to be 160. So we could put that here. We have the first term to be 4. And we have the common ratio to be 3. And the goal is to find the value of n. So this just requires a little bit of algebra. So we're going to put this 160 over 1, and we're going to cross multiply. But maybe before we cross multiply, we can simplify this. So this here is 160 over 1 equals 4 parentheses 1 minus 3 to the n over negative 2. Now what I did here in this numerator was I saw that there was a GCF of 4 out of both of these terms, and I divided 4 by 4 and got 1, and then this term, negative 4 by 4, and I'm just left with 3 to the n. This is just another way to write it. I'm not sure if it's necessary, but it was just something that I saw. So now we're going to cross multiply. We're going to take negative 2 and multiply it by 160. And that gives us negative 320 equals 4 parentheses 1 minus 3 to the n. Now we can divide by 4, and that gives us negative 80 equals 1 minus 3 to the n. Subtract 1. Negative 81 equals negative 3 to the n. Divide by a negative. So 81 is equal to 3 to what power? So you could actually just do common bases here. If you know that 3 to the 4th equals 81, then cross off the bases, and 4 is equal to n. Okay, now let's see if we can move on to example 4. Find the sum of this sequence. So it says 7, 10, 13, and you see these dots? Dot, 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 all the way up to 49. So we're not really sure how many terms there are here. Now, you could count until you get up to 49 and then do it, but let's see if we can figure this out without it. So let's figure out, is this arithmetic or geometric? 7 times, no, okay, 7 plus 3 plus 3. Okay, I like that. So I have a common difference, d, of 3. So we have S sub n equals n, a1 plus an, all over 2. So we don't know how many terms there are, so this n is a little tricky. That part we don't know. But we do know a sub 1, which is 7. And we need some spots here. So it looks like what we need to find out is how many terms there are between here and here. And the really only way to do that, besides counting, is to use this explicit formula. So a sub n equals a1 plus n minus 1 times d. So we can use a sub n to be our last term. So we could throw in 49 here, 7 here for the first term, and we don't know, that's what we want to find, and my common difference is 3. And we can distribute this 3 in, we can combine like terms with the 7 and the negative 3, so that's 49 equals 3n plus 4, and solve. Subtract 4, and n is equal to 15. So that means I want to find the sum of the first 15 terms. So 15 is here, and the next piece that I would need to finish the formula is a sub 15. So the sum of the first 15 terms is 15, 7 plus the 15th term over 2. So a sub 15, technically we already know. We know a sub 15 is 49. That's my last term. So we actually can go ahead and plug 49 right in here. And then calculate this and hit resume when you're ready to see the answer. Okay, I got the sum of the first 15 terms to be 420. Alright, let's move on to the last question. So it says an auditorium has 21 rows of seats. So if you think about it, we've got seat rows here, 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 right? They all have 21 rows. And we say the first row has about 18 seats. And then it says each succeeding row, so each row thereafter, has 2 more seats than the previous row. So 20, 22, 24, and so on and so on. So they want to know how many seats are there in the auditorium. So realistically, we want to add how many seats are in this row, plus this row, plus this row, all the way up to those 21 rows. So if you think about it, this is actually an arithmetic sequence because I'm going up by 2 each row, they're adding 2 more seats. So we know my D, my common difference, is 2. So we know the formula for the sum. What do we want to find, though? The sum of these 21 rows. So S sub 21 is what we want to find. Well, let me write the formula first, actually. So S sub n equals n A1 plus AN over 2. So S sub n, well, now we can actually plug in n. N is the 21 rows, so 21. And my A sub 1, my first row, has 18, plus A sub n, A sub 21, all over 2. So in order to finish this problem, we need to know the value of that last row here. That has 21, the 21st row. How many seats would it have? So we actually have to use that other formula, that explicit formula. A sub n equals A sub 1 plus n minus 1 times d. And we want to find A sub 21. So my first term is 18. There are 21 terms, so that's n. And my common difference is 2. So if you take a minute, plug that into the calculator, pause the video, and then hit resume when you're ready for the answer. Okay, I got 58. So my 21st term is 58. So S sub 21, the sum of the first 21 terms, is 21, 18 plus 58, all over 2. So type that into the calculator and then hit resume when you're ready for the answer. Okay, I got S sub 21 to be 798. So in that auditorium, there should be 798 seats total. Alright, that's it on the sum formulas for arithmetic and geometric finite series. If you have any questions, please jot them down, and we'll see you in class tomorrow.